Alright, in this video we're going to be cutting the slots. So the first thing you see me do here is I'm just holding the part up to where I think it should be in the vise, and then I'll take a quick measurement with my ruler so I can get the right pair of parallels the first time. Now you're going to be doing two parts, I'm doing one, so you're going to want to have a stop set against your back vise, which I do add, but it's not there right now. So when you are building your setup, make sure everything's perfectly clean. You see me wiggling the parallel around, and I'm taking a piece of banding to use as a parallel keeper. And that's going to help prevent chips from getting behind my parallels. But always be paying attention. So my part, I got my layout lines. I'm setting it up to the right side of the vise. Like I said, I should have a stop. And then if I had two parts that were identical, nearly identical like you will, I would have the other part in the other side of the vise to help keep my jaws, my movable jaw, even. So right now it's actually probably kicked a little bit. It's probably biting harder on the left corner than the right side of the V block. Now calculate your RPMs for high speed still, please. These big 4-inch cutters, they don't like it if you don't calculate your RPM, and they're kind of expensive. So let's do that. Now I'm just gonna bring the knee up here. I'm already down against my spindle stop, like always. I'm bringing my knee up until I touch. You can hear I just touched off, and then now I'm moving off to the side, zeroing my knee off camera, and then I'm going to raise the table to a 1/4 inch because it's a 1/4 inch wide wheel cutter. Now from that 1/4 inch I can look at my print and figure out how much more I should raise the knee in order to get my cutter positioned correctly. And I'm showing you, hey look, it's flush. Now, remember, the numbers on the print are different than the numbers of your block size right now because we've only roughed it in, and the print is giving us finished dimensions. So remember that when you're making your adjustments after you touch off. Alright, so the next thing to do is to start the spindle, and then I'm going to bring the part over against the cutter in the x-axis, and as soon as I touch, I'm going to zero out the readout. I'm also doing a little visual confirmation and making sure that it looks like it's in the correct location. That's, after all, why we put layout lines on parts, is so we can make sure that we're not doing operations in the wrong spot. So I touched, I'm going to zero the X. And then I'm going to make my calculated adjustment. And there I am, I'm just showing you, look, my touch off mark is right in between the scribe lines. So I'm happy with that. Definitely you want to be running a flood coolant if the machine you're operating has it. And like I said, that's high speed still RPMs, and that cutter, it might have 36 teeth. I'm not feeding it as hard as it could be fed if it was a cut being performed inside a horizontal mill that had a outboard support. That little arbor, I don't push it very hard. I can't recall the exact inches per minute, but you can get a good idea. I'm not going too fast. Now most of these clips I'm going to speed up to 400%. Yeah, just to get across this part. in a somewhat timely manner. And even without speeding it up, it's actually rather impressive how fast a wheel cutter can remove the material. So I've cleaned everything up, do a quick little inspection, and then since I have my stop, I can set my part back down, clamp it down. Now since I have my spindle stop set, I just raise up the spindle, jog the table to the starting position, and then I can lower it back down. And then just turn on the spindle, turn on the coolant, and make the cut. So you'll be making this cut 4 times total. And that's why we want to make sure that when we're roughing in our blocks that we're keeping them within a couple thousandths of each other for their sizes. So that way you don't have to make any special adjustments. You just take a cut, rotate your part, take a cut, switch to your other part, and just keep on cutting. Now this cutter, I mean, you can hear that it has some run out on that arbor, and you'll see a fair amount of run out in the 1/8 inch wide cutter here in a second. And it's not as accurate the way I'm touching off since the cutter has a lot of run out. But I've found with this arbor, even if it's been remachined, the surface, the mating surface for the wheel cutter, um, it's just not going in and out of the spindle and retaining its accuracy. I wanted to include this right here. So when I'm switching my cutters, you have to get everything perfectly clean. No, there's no excuse to have chips or debris trapped in between the surfaces. And I kind of try to show you, and well, you can kind of see it on the arbor where other people, students before have been careless and trapped small bits of chips in between the surfaces. That's what I'm showing you there. All those dents, that was avoidable. So make sure you're wiping it. And the direction we load the cutter, it is important. I don't want to talk about it on video, but ask me in person. We'll talk about it. All right. Here's the 1/8 inch cutter. Like I was saying, it has a little bit of wow to it. It runs out. But that's okay. It's going to be just fine. Now you can probably hear where I touch off. And then I just do the same thing that I did with the 1/4 inch cutter. I'm going to raise the table. I'm going to come over an X. I'm going to touch, 0 the X, and then raise the knee some more, get my cutter in the center of the part, and move over my X distance, and then just take the cut. And I feed both of these cutters, the 1/4 and the 1/8 inch. I just feed them at the same inches per minute. And if you're unsure of the number that you come up with, go ahead and hand feed, and then get comfortable with the resistance that you feel against the handle, and then you'll look up and where it says feed, you'll see it says 2, and then you can switch your power feed to where it is going 2 inches per minute, and then be happy with that. So you can always double check if the number seems like it's really high. Maybe don't adjust the power feed to that number. Maybe hand feed it for a second and see if that number is something that you want to actually engage the cutter against your part with. I got a little tongue-tied there. So yeah, moving over, I'm paying attention. I don't want to hit either the stud that's holding the vise down, or the arbor against the side of the vise. So be aware of every aspect of your setup. And it doesn't take a lot of coolant, and all you have to do is hit the arbor with it, and then centrifugal force will sling it um, across the cutter. So with these machines like this that don't have any enclosure around them, it's really easy to make a giant mess. So you always have to be paying attention to your coolant. Now, I edited the print after I made this part. Um, I don't cut the V's as deep as they are, or I meant to say the relief cut right here as deep as I am. Um, it was just excessive. I I'm not sure. I think I shallowed it by maybe 80 thousandths, but there's still plenty of relief. That was just one of those things where the print, I had never modified it, and then when I was making one, I started looking at it and I thought, that's a lot deeper than it needs to be. What really caught my attention is for a second I thought I had messed up. Now I'm flipping it around, making sure the parallels, everything is clean. I'll clamp it down, reset my cutter, and I'll make the cut. So this video is pretty much over. I don't think you're going to see anything new on this side. Try not to forget that your X distance is going to be different from part to part, side to side. Pay attention to your print.